Okay, we have 5 times x minus 3 quantity squared. That equals, we could try to break this down as a over x minus 3 plus b over x minus 3 quantity squared. We would end up with the conclusion, if we go through the arithmetic, that ax has to be 0 because there's no x term over here. And since ax is 0, your negative 3a plus b is going to equal plus 5. A is 0, so b equals 5. So now a is 0, b is 5, and we find that 5 over x minus 3 quantity squared will be 0 over this and 5 over this, but that's just 5 over this, which is the same thing we started with. Since we don't have two different linear factors in the denominator, there's no need to do the partial fraction. In this case, we just have a constant number in the numerator. And I had an example here. I guess I'd better do it real quickly. By contrast, if we had 2x plus 5 over x minus 2 quantity squared, then we would need to do what we started to do when we just had the 5. And this time, you're going to get an ax from this. You're going to get a bx, which is going to give you a 2 for b, and you're not going to have 0. Oh, good heavens. Yeah, well, it's going to be 8 that's 0, but anyhow. Okay. So that's going to be a times x minus 2 plus b over x minus 2 quantity squared. Skipping steps here because we're pretty good with everything. All the details. So we would have a equals 2 in order to get the 2x, minus 2a plus b equals 5. Well, since we know a, it's 2. We would get a value for b, and that would be 9. And our conclusion is that 2x plus 5 over x minus 2 squared equals 2 over x minus 2 plus 9 over x minus 2 squared. And now we have a decomposition. Okay, then another example. If we have an irreducible quadratic and a linear function in the denominator with a numerator of lower degree than the denominator, then we're going to do a over x minus 2 as we always do with a linear factor. But we're going to need a bx plus c on the quadratic factor. Okay, so we just do the arithmetic and multiply numerator and denominator here by the quadratic, numerator and denominator here by the linear function, and we're going to get this form. Now I went ahead and distributed the a through this addition, but I left the bx plus c times x minus 2 here just so I wouldn't make a mistake. Doesn't mean I didn't, but okay. Then we can expand this, we get this mess, and we see that we have two x squared terms, one from the bx plus went from the bx and the x here, and we get an ax squared and a bx squared, which gives us an a plus b times x squared. And then here we have a c minus 2b times x to go with the ax, giving us a plus c minus 2bx. And then we have finally a minus 2c. So the coefficient of x squared has to match here, so a plus b has to be 5. The coefficient of x has to be 2, so a plus c minus 2b has to equal 2. And the constant term a minus 2c has to equal your minus 7. And then we just solve for a, b, and c. And hopefully that answers your question about how many factors of the denominator and so forth.